All right. So, steps for finding the inverse of a function. We have already done this. We just haven't done it with logs and exponentials, right? We are going to switch the x and y. We're going to solve for the new y. We're going to replace that y with f inverse of x. Then we'll use Desmos to check to make sure our answer looks right. So, this is just a chart on checking for Desmos, giving you some examples here. This part right here, there is one more way you can check, but it confused people last year, so I think I'm going to leave that out. So we'll just stick to what we have been doing. So if we want to find the inverse of g of x equals 3 to the x plus 1, we are going to start, this right here is like our y. We're going to start by switching our x and our y's. So we're going to have x equals 3 to the y plus 1. Okay, so you guys write this down so you got some examples to look back at. All right, and we need to solve for y. So it's like solving equations, but we're not going to get like a number answer for this. We'll get a new equation is what we're going to get. So if I am trying to get this y right here by itself, Camel, what do you think we should do first? We either have to get rid of the 3 or the 1. Which one do you think we should get rid of first? Good. We're going to get rid of that 1. How are we going to do it? We're going to subtract it. Because it is not in the exponent, we can just subtract it and move it over. Can I do x minus 1? I cannot. Those are not like terms. So I just have to write x minus 1. In a way, it's almost easier because you don't actually have to do any of the math, right? You just kind of write it. Okay? Now we're trying to still get to that y right there. Jeremy, I got to get rid of this 3. How am I going to get rid of that 3? I can't divide it because this is not 3 times y. It's 3 raised to the y power. What's the opposite of having 3 to a power? It's a log. So I need to log base 3 this side, which means I'm doing log base 3 of, make sure you put some parentheses because you're log base 3 in that whole side over there. Not just the x, but the whole side, whatever's over there. So we're going to get log base 3 of x minus 1 equals y. Usually we'll rewrite this with the inverse notation, so we'll say g inverse of x equals log base 3 of x minus 1. What you should see, if you started with an exponential, you should have a log somewhere in your answer of some sort. Let's check this using Desmos. So we have g of x equals 3 to the x plus 1. We got our inverse. Remember that Desmos is not like inverse notation, so we're just going to say y equals log base 3 of x minus 1. And if we graph y equals x, and I'm going to make that one dotted. Okay, does that look symmetric to you guys? I think so. I feel pretty confident in my answer there. Okay, questions? All right, let's keep going. Let's do a few more. Okay. All right, so if we do example 2, first thing we got to do is switch our x and our y's. So we're going to have x equals 4 to the y minus 2. We are trying to solve for that y right there. Angel, what do you think we should do first? Very good. We're going to add that 2. So we've got x plus 2 equals 4 to the y. All right. Then I'm trying to get to the y. I got to get rid of that 4. Keely, what do you think we should do there? We're going to use a log with a base of 4 Over here, it just cancels. Over here, we're going to have log base 4 of x plus 2. So log base 4 of x plus 2 equals y. Since they didn't use f of x notation, I think I'm just going to leave it like that. Let's check it. If we graph y equals 4 to the x minus 2, that looks like this. Y equals log base 4 of x plus 2. That looks like this. Does that look symmetric to you guys? I think it's good. They cross, and they cross on that green dotted line, right? If I had, let's just say I got like a minus 2 right here, which would not be right. You can see that's not symmetric. That would let you know, oh, I think I messed up somewhere for that. But we had a plus, so that works fine. Okay, now 3 is a little bit different, right? It's a little different than the one that we just did. We're still going to switch our x and y. So x equals 3 to the y minus 5. And we are trying to solve for the y right here. Let's see, Kaylee, what do you think we should do first on this one? Good. We want to log 3 because we cannot do the plus 5 yet because it's up in the exponent. See how there's a difference here? This one was just like out towards the end. This one's up in the exponent. So we are going to do the log first on this one. So we're going to do log base 3. So we get log base 3 of x equals y minus 5. And then, Joseph, what do we need to do after that? We're going to add the 5. Now, when you add that 5, this x right here is in the log. You can put parentheses or not, but the 5 can't be added on the inside of the log. It's just like over towards the end. So it's going to look like this. Log base 3. It can look like this, x plus 5. Or if you want, you can put parentheses just around that x. If they're not written, it's assumed it's just around the x and the 5 is separate. Let's graph it to see if it looks right. I've got y equals 3 to the x minus 5. And then I got y equals log base 3 of x plus 5. And that looks good. Notice if I had like this in parentheses, see how it would not look correct? You've got these that are crossing, but they're not crossing on the green dotted line. It is a little symmetric looking, but if they cross anywhere besides the green dotted line, then it's not right. It's not the right answer. So that 5 is over on the end for that. Okay, that was one thing we were getting a little mixed up on the quiz about, is sometimes we were, like, on a problem like this, we were not adding the 2 first like we needed to, or we did try to add the 2 when we shouldn't for that. Okay, questions? All right, those are our exponentials. We're doing inverses and we're getting logs. Okay, let's look at some logs, and we're going to see that we're going to get exponentials for our answers for those. So if we look at example 4 here, we're going to switch the x and the y. So we got x equals log base 5 x plus 2. And once again, unless they have parentheses written, the parentheses only go around the thing that's right after the log. Oh, it doesn't. Yeah, it needs to be a y. Sorry about that. For some reason, this thing is not letting me erase. I don't know why. Well, let me just write it correctly. Let's see. X equals log base 5 of y plus 2, and parentheses are just around that y. Right there. Okay, so if I want to solve this one, I'm trying to solve for the y right there. Jasper, what would I do first on this problem? I need to deal with that too, but I need to subtract it because it's already positive, so I'm going to subtract it. So I'll get x minus 2 equals log base 5 of y. And again, I'm trying to get to that y, so now I got to get rid of that log. Alex, how would I get rid of that log? Okay. And to do that, I'm going to use an exponent, right? So I'm going to do like 5 raised up to the power. That'll get rid of this. I got to do 5 to the power here. You might want to put like some parentheses around it or something. That whole thing is being raised to the power. So I'm going to get 5 to the x minus 2 equals y, or y equals 5 to the x minus 2. And if we graph it to check it, we're going to get y equals log base 5 of x plus 2, and we're going to get y equals 5 to the x minus 2, and that looks good. That looks symmetric there. Okay, questions there? Oh, 5 is thrown in a natural log. What is the base on a natural log? It's e. So whenever we see this, when we switch our x and y's, we got x equals 3 natural log of y. It's not written, but natural logs have a little base of e right there. So if I'm trying to get to the y right here, what should I get rid of first, Trinity? Not the e on this one. The 3. It's whatever's furthest away, and that's your 3 here. How do I get rid of that 3? Good. You're going to divide because it's right next to that natural log, which means right now it's being multiplied. To get rid of something multiplied, we have to divide. So we're going to divide both sides by 3. You cannot do x divided by 3, so just write it as x divided by 3. And then we got natural log of y, and I'm going to write that little e, even though it's not necessary. Okay? And so now, Jeremy, how am I going to get rid of that natural log right there? What? Not log it, because it's already a log. Raise it, good. So we're going to raise it to the power e to the power here, e to the power here. So I've got e to the, I'm going to put some parentheses here just to make sure everybody knows that's the next one. You don't have to have them, but you're going to have them whenever you type it in Desmos. And that equals y. So let's check it. Y equals 3 natural log of x. Y equals e to the x over 3. That looks symmetric. That looks good. Okay, questions? All right, let's see. You guys try the next ones on your own. So 6, 7, 8, 9. Try them on your own. And then we're going to see how we're doing.